The first module. This is section 1, and we're talking about relations and functions. So first things first, you need to understand what the vocabulary is here. A set is a collection of objects. An ordered pair is made up of an x value and a y value. The x value is called an abscissa, and the y value is called an ordinate. It's not used very often, but every now and then it is. All right. Relation is a set of ordered pairs. The domain is the set of all abscissas of the ordered pairs, and the range is the set of all ordinates. So the domain is all the x values, and the range is all the y values. Okay? And a relation is not very specific. It's just a collection, which is a set of ordered pairs. So right here, you've got a chart, and you have unseated clouds and seated clouds. And it says, state the relation of the rain data above as a set of ordered pairs. Also state the domain and range of the relation. So here you go. It started at the bottom. The relation is 28.6 and 119. So each of these is presented as an ordered pair. The x and then the y. Okay, so this grouping right here is your relation. It's got all of these values in there. Now, they wanted the domain. You do not have ordered pairs here. There's no parentheses. What you have, these, I know it's hard to see, but they're little brackets. And they're each number listed here. 1.0, 4.9, all the way up to 28.6. And then it closes off this way. The range, okay, are all your y values right here. And they're listed the same way your domain was listed, with the brackets and then individual numbers right here. They're not points. They are individual numbers. Okay, these are different ways that you might see relations represented. You've got a mapping here. This is the domain, and it maps to this. You've got 1, 6, 2, 4, and 3, 2. That's the relation right here that is mapped. Could be on the coordinate plane where you just have points, and you'd actually have to see what these points are. That is 1, -1. Okay, 2, -2. You'd have to come up with them. This is set notation, where you have the bracket and then the points in each place. Or a table of values that we just had. Had both of those, set notation and table of values. It can come either way, though. All right. So then you've got to decide, is this relation a function? A function must have a different output value for each input value. So right here, this function 2 going to A, B, and C is not a function. And I always think of it in terms of the coordinate plane because of the vertical line test. That's coming up on the next slide. But if I've got 2 going to A, going to B, and going to C, it all lines up on one vertical line, which is not a function. This second one over here, I've got A, B, and C all going to 2, but each vertical line is fine here. There's no problem with that. So, actually, there's the vertical line right here. If you're drawing it through and it only hits it one time, it's a function. If it hits it twice, it's not a function. So usually that's how I test in my head when I'm trying to come up with it. But it's easy enough to decide here as well. 2, 4, 6, 8. I've got all different x values here. So it really doesn't matter what my y values are because I don't have any x values repeating. So this would be a function. Okay? Yes. From last name to social security number, well, my last name is Casbero, but so are my 2 boys and my husband. So all 4 of us have a different social security number, but the same last name. So Casbero has 1 last name, but goes to 4 different people. So that would not be a function. But no, not a function. Okay. Right here, I've got all different x values going to the same y value, but that doesn't make any difference. They're all different x values. So that is a function. This one right here, from the number of items in a grocery cart to the total cost of the items in the cart, not necessarily. I could have 4 very cheap items, like gum and candy bars, and be a cheap price, say, $5. But I could have 4 steaks and a couple of lobster tails in there. Well, that's going to be quite expensive, okay? So you can have the same number of items going to different, so that would not be a function. Okay, the vertical line test that I told you about, if it passes through, and only if it passes through more than once, it is not a function. So, and that's what I was telling you guys to look at carefully. If you've got one that crosses the graph in more than one place, and you can see no matter where I draw the vertical line, it's going to hit it in 2 locations. Unless I do a tangent line at the end, but still, it's not going to be a function because it can only hit it 1 time. Okay. There are a couple that I would have you guys look at. When you've got functions that you're trying to decide based on the vertical line test, you might have a graph that looks like this. You might have a graph that comes up and has a dot, and then one that goes like this. If you draw a vertical line through that, this will be a function. It's not a continuous function, but it will be a function because it only hits the graph 1 time. Okay, so that's yes. If you've got the same graph, only this is colored in and this is colored in, that is not a function, because when you draw a vertical line right through those 2 points, it is going to cross it in 2 places, so that would not be a function. Those are things you have to watch out for when you're looking for it. It's like I said, it's not continuous, which means you can draw it without picking your pencil up, but it is a function still. Okay. So this is all about using the vertical line test, and they actually have one down here that I was talking about right here. Okay. So, we've got right here that passes the vertical line test just fine. This one, however, does not, that we just talked about. This one right here, I've got 2 points right there, one on top of each other, and 2 points again on top of each other here, so that would not be a function. This one right here, no matter where I draw it, it's only going to hit it once, so that's yes, it's a function. All right, so we're about 9 minutes right now. Let's stop this, and I'll work on number 2 in just a second.